webinar. I am Frank Kenya with Voice and Data Networks. I'm going to take a couple of moments here to introduce you to Voice and Data Networks and also to Chris Ellerman of Meru Networks, who will be our featured speaker this morning. So just a brief overview on VDN. VDN is a technology solutions and service provider based in Minnesota that designs, implements, and maintains converged communication networks for enterprise customers nationwide. Founded in 1994, VDN specializes in solutions for voice over IP, unified communications, networking, maintenance applications, and contact centers, enabling businesses worldwide to achieve marketplace advantage. VDN services provide small to large companies comprehensive service and support, resulting in exceptional service, improved productivity, and business results. It's definitely a case of our experience is your advantage. A brief intro to Chris Ellerman. He's a systems engineering manager supporting the Midwest, United States, and Canada with Meru Networks. He joined Meru in 2007 and has an education in electrical and computer engineering and business studies, and has experience in bridging technology and consultative offerings to the benefit of Meru's customers. Without further ado, I give you Chris Ellerman. Chris?
Thanks so much, Frank. I have a couple slides here on who Meru is. So for those on the call who may not know, Meru is a 10-year-old company, and we design and build high-performance Wi-Fi access points, controllers, and software to manage those systems. We have a very unique wireless virtualization architecture, which I will touch on during this presentation. And that architecture really has proven out to offer our customers best availability, reliability, and really especially in high density and bandwidth intensive environments. Because of that, you'll see key industries that we are in, and early adopters for this technology tended to be in healthcare and in education. We do have over 6,000 customers worldwide. We have partnerships with other technology customers that are certified to work with our solution. And we also have a worldwide channel partner program, which brings us great companies like VDN that we can work with to deliver you a solution. I want to shift to architecting the environment. And what's interesting is when you think about the mobile edge, a lot of times you're thinking about a pure wireless architecture, but because of the phenomena of BYOD, because of different changes in the standards to the wireless edge, it is actually affecting the wired side of the environment. So I have an 802.11n, and I say 802.11ac up here. Most of you, I would assume, are familiar with 11n technology, high-speed wireless. 11ac is the next generation, and I'm going to touch on that because it's important to understand what's coming very soon in order to architect. So if we look at what's happening today, the BYOD as well as the increased wireless speeds are really driving this need for additional bandwidth growth on the edge. And mobile applications that are running on devices such as iPhones or Androids are really taking the demand from clients and customers to mission critical and rising demand. About 5 years ago, when I joined Meru, we were oftentimes working with voice products that were on a dedicated platform, maybe a dual mode phone. But today, with BYOD and the environment we're in, these applications are oftentimes running on consumer devices. So this is changing the requirement and how you design and support that. Taking this a step further, not only is there a change here in what the wireless edge is doing, there really is a change in the wired network and back-end servers that is occurring. And I'll touch on that during this presentation as well. And finally, because of this change, I'm really seeing a shift in the industry right now into a change in operational model. And that's skill sets along with the processes and tools that people need to incorporate to effectively manage their wireless network. So that's kind of an overview of what I'm going to touch on here. And I do want to start, I know there was a large presentation on the BYOD phenomena yesterday that VDN put on. Hopefully you attended that. So I'm not going to spend a tremendous amount of time on BYOD, but to point out a few stats here of real interest I find real interesting. The first is actually over on the bottom right, where it talks about average hotel internet session growing from 5 meg to 15 meg. So for those of you who are on the road, like I tend to be, you're definitely in hotels using their wireless network and their environment. Typically not as nice as your home environment or your enterprise environment. But it's very interesting to me that the bandwidth already between 09 and 11 has been driven up. And largely that is this, again, BYOD effect, people using their iPhones, people bringing tablets into that environment, and bringing a lot more video and multimedia content even to the hotel space. Additionally, we see 100 million units shipped by 2012, and clearly we've seen the explosion of tablets, and I'll touch on some other stats here as we move along. But this whole dynamic's really changed since 2007 when the iPhone was brought to market. So this explosion, again, over the last 5 years is really driving this need on examining and architecting and managing correctly your wireless mobile edge. So there are some challenges with tablets, more so than your average laptop. And there's quite a few listed here. But the one I do want to concentrate on really 2 points, is that for the most part, the antennas that are in wireless tablets are not as strong and solid as your average laptop or desktop. Clearly, the tablets are being designed for portability and aesthetics, and the antenna is going to be put in that sort of device the best that it can be done. So what I'm actually showing here is a picture on the bottom right. Was an education customer of ours that about 2 years ago called us up and said they were having tremendous problems. And I believe these were all new iPad 2s. And what we found out when we went out there, you can kind of see the two on the right are actually propped up just a little bit. But those two tablets were having no problem connecting 100% connectivity. Tablets that were flat on the table were actually having some problems. So some of these add-ons and accessories that we see for tablets actually have a functional aspect other than just the ease of use. The other thing that's pretty important about the tablets and the BYOD devices is that they often are in the use the 2.4 gigahertz spectrum. And again, going back to 5 years ago, typically when we had mission critical devices, they were often dual mode, and wireless engineers would often want to design networks up in the 5 gigahertz space, which is completely regulated, because that 5 gigahertz space would be clean and we could guarantee very solid quality of service. So now as these consumer devices are coming on, for example, an iTouch is 2.4 only, a lot of the droids could be 2.4 only, you're not certain what's walking through your door, it becomes a challenge, and challenge really for the following reason. If we look at the 2.4 spectrum, it's an unregulated space. So that means besides just your wireless devices, you'll find Bluetooth, you'll find standard phones, and you also find devices such as microwaves that create a lot of noise in an environment. So if I look at this 2.4 spectrum, and you'll often hear RF engineers talk about channels that they're using simply because we don't want to talk about 2.412 megahertz. What you'll find is that there's 11 channels we tend to use in the U.S., and you'll often find engineers talking about using channels 1, 6, and 11. And that's because when the signal is centered on there, you do have some sideband energy and signal that goes out. If they place them on 1, 6, and 11, they don't interfere and can get the most coverage. Well, one thing you may want to do if you go home and use your microwave tonight, I think this is kind of a dirty little secret that our competitors don't like to talk about, is that you're going to find your commercial microwave operates in this 2.45 megahertz space. And I actually have a picture here of the microwave in my house that does show that. Sorry, a little blurry there, but it does say 2450 megahertz. So what does that mean? It effectively, when you have a microwave, it can really eliminate channel 6 and 11. So I've moved over to show you the spectrum again and really drawn a line down here of where the microwave is centered. So traditionally what you'll find when we go into environments is that the microwave, though it's centered there, the energy absolutely gets dispersed over in adjacent channels. Traditionally and typically it goes up rather than down, so channel 11 will tend to be taken out of play, and then a lot of times channel 6s as well. So it becomes a challenge when you're using a traditional microcell wireless environment when you need to operate with all three channels to support these BYOD devices. So the good news with Meru, and this is actually a screenshot of a Spectrum tool of ours, and I use this in my home, and you can see there's, when I turned on my microwave, it brought out a very strong signal, neg 25, effectively wiping out those upper channels. That's what the red energy is showing down here. But the great news about Meru and our virtualized RF architecture is that we can deploy adjacent access points on the same single channel. It's a unique differentiator for us. So as we go into environments where we do have microwaves or other interference, we really do focus and target on just give us one clean single channel, and we can give you clean connectivity for your BYOD devices as well as your existing traditional laptops and such. So we'll talk about this technology in a little deeper going forward, but what I want to do now is really shift to the concept of what mobility really is, and the fact that it really is the default access in technology. In my world, in the way I've been there, as I've worked for Meru in the last 5 years, I look at wireless Wi-Fi technology as the default access into your network. But it really is, for those organizations or those industries that weren't on the leading edge, it really is becoming the default today. Or I'll argue that it's definitely going to be the default in the next 18 months for employees of your company or your students to access network resources. So just pulling up a study from an analyst here. This one happened to be from IDC. It talks about that devices without Ethernet ports surpassed those with in shipments in 2011. So clearly the consumers are speaking as well as the enterprises in buying devices without Ethernet ports. So therefore they're connecting via Wi-Fi. So the other aspect is what is the experience of the people that are walking into your organization, be they guests, be they your employees, be they students. So going through this picture, this is actually a customer of ours based in England, and they're running out of room, this K-12 educational facility. So they're having classes and taking tests in a gymnasium. So these are actual pictures, and you see the kids all raising their hands. They're doing a test before the reason they're raising their hands, they were being asked if they could access the test materials that were being video streamed to them. So these are what students are now starting to experience, and it's what they are expecting. So obviously as they graduate, get older, come to the world that we live in, their expectation is they're going to have that seamless mobility. So not only if you're a student is that your expectation, but everyone as they are going about their daily life is really starting to use this mobile technology as well. So if you look at the top right, that's actually a picture or outline of Fenway Park. So Fenway has been, in Boston, has been a customer of Meru's for approximately 2 years. And initially, while not designed such, what we're working on now is to be able to provide Wi-Fi connectivity in every seat in the stadium. Initially it was 10–20% that they were focused on, but what we are finding is that people are using Wi-Fi at sporting events and connecting in, really wanting that experience. Now clearly the Boston Red Sox can use that for promotions and the like to target their clientele, but it is something they're expecting. On the bottom right is the new Florida Marlins Stadium that just opened up, also a Meru customer. And again, designing this so that every person, every spectator can get a Wi-Fi connection. So clearly that's a lot of investment for the organizations to put out, but it's what the clients are demanding, and again, they can leverage that to target their clients. The picture on the left, it's the Super Bowl halftime show. So I'm not necessarily a huge Madonna fan, but the interesting thing about this is what you see in the background. You know, back in the days, and depending on date, what you tend to see is people holding up lighters during these events. But here, actually, what you're seeing there is you're seeing a ton of either iPhones or Droids with people with apps on, you know, creating that same effect. And I was actually watching the Super Bowl along with some other Meru engineers at the time, and I just remember one of them going, "Oh my Lord, look at all the 2.4 Wi-Fi devices in there." So this really is the world that we're entering. So it's the experience that that people have outside of work, and it's also the experience they're going to want to have when they do come to work. And here's an example of work. This happens to be a picture of the Chicago Mercantile Exchange, their floor. All these traders carry a wireless device with them, and they've been running all of their trades over a Meru wireless system for about 3.5, 4 years now. So clearly the need for density, the need for a fault-tolerant, the QoS ability, so every trader gets the same experience, is there. So this whole mobile edge Wi-Fi experience really is becoming untethered. You know, users can be dense at times depending on where they are and what's happening, and the devices can be very diverse that are coming on the network now. So gone are the days where it's simply we need to have the end user's laptop on board. The other aspect is that, you know, even when someone's connecting, I don't care if it's the sports stadium, at your work or at home, they're running multimedia. The applications on these devices we're all very familiar with. So clearly we need to design and architect a system that can support this random diversity, this multimedia, giving these applications the bandwidth and QoS that is required. So let's talk about the existing 802.11 architectures that are there today, and then also we'll talk a little bit about some challenges with 802.11 and how Meru has engineered around these challenges. So looking at this screen, there's a curve on the left, this contention loss curve, which I'm not going to go into it too deep from the RF Wi-Fi perspective. What I am going to do is use an analogy, and it's an analogy back to approximately the mid-90s when we were using hubs. And if you think back to that point in time, when we were connecting obviously from wired, using a wired connection to a hub, that hub is a shared medium, a lot like the RF or the in-air space. It's a shared medium. So for those who remember the 10 meg hubs back in those days, if we started plugging in clients, the more clients we started plugging in to that hub, their actual total bandwidth available to them would go down. And this was based on the fact that they would all try to want to communicate on this shared medium at one time. The devices could actually detect if there was a collision on that shared medium, and then they would back off a random amount, a random set of time, and try to retransmit. So if you just put 2 or 3 devices on a hub, and that's all that was there, you get a lot more throughput because essentially, if I have 2 or 3 devices, they're just communicating with each other, oftentimes just a one-to-one communication, and so there weren't issues on a shared medium. As you started expanding, adding more clients, again, that total throughput would come down. So back in the 10 meg hub days, we used to say with a lot of users on, you're going to get 3 meg of total throughput between all those users. Now, if I shift that same concept and talk to you about wireless, wireless is also that shared medium, but the difference is that in a wireless environment, the end devices cannot detect collisions. So the algorithm used is actually called collision avoidance rather than collision detection. And the long and the short of it is a generic wireless access point is going to have to back off more often if they believe that there's contention in the air, or back off for a longer period of time. Just can't be as aggressive. So this is why also if you've gone to Best Buy and picked up a wireless router, you put it on at home, typically the wireless devices at home, while you may have more than 3 wireless devices, there's probably only 2 or 3 at one time that are really trying to use that RF medium. So you don't see this whole issue of contention loss at home. Then as you come to an office space, if you use that same sort of access point that was using that same sort of algorithm, what you'd see is you got more people into a conference room, as you got high density in auditoriums, you would just end up with essentially an environment where there's nothing but contention in the air. So 802.11, when it was first designed and implemented, was based upon a client choosing what access point he'd go to. It was designed from an aspect of convenience rather than mission critical. So it's a real problem that the Wi-Fi industry has had to address. So to kind of summarize these traditional enterprise wirelines that are out there, traditionally the client is in control and each device is going to choose where it wants to connect. So if it happens to choose an access point that's not providing the best speed and signal strength, it could slow down others in the environment because, again, it is a shared space that they're using. And the devices would decide when to break and roam to others. So the result really was chaos, if you will. So, if you just dropped in an access point and as scale started to happen, we see these Wi-Fi networks essentially tip over. So there wasn't consistent reliability, hard to provide QoS at that point in time as well. So one of the things that makes Meru different, and we'll talk about this in a little more detail on the next slide, is that Meru actually controls the clients. We make it look to the client like there's only one access point. So because of that, we proactively take the choice away from the client. The client will then, based on the network being in control, be connected to the optimum access point. So we select that best access point for that device. We monitor all devices in the air as well as all the access points in the environment and proactively choose what the best experience will be for that individual client. And we also look at it at an overall system level to make sure we're getting the best and most throughput through the system. And the result of this is really this rich interactive experience for the end user. So if you look at Meru and what we've done, we've really done a lot of work going back, if you think of that curve and that contention management, in order to optimize the RF and such that we've optimized it to the point that we can actually have adjacent access points running on the same channel because our system can see every client in the air, knows every access point, and because we're providing that one-to-one relationship with the client, we can be more aggressive with those collision algorithms. We can manage the clients, tell which ones to back off, give priority to those that are in the multimedia space, such as voice or any other application that's defined. So it really does provide a system approach to a protocol that was designed for an end client to be in control. So this is unique, completely unique to Meru. And a lot of times when I'm speaking to people directly, I kind of get that look of, gee, I don't know that this can work in Wi-Fi because, we're used to doing this 1/6 and a level, changing channels. But you may just want to think of it like you think of the cell phone network. The cell phone network that you use every day, the towers, the network, the system are in control. Your iPhone, your BlackBerry is not choosing which tower to connect to. The system controls that for you. So Meru is architected in that manner from the ground up. This also provides us some very unique capabilities to take it a step further. Now that we are encountering this wave of BYOD devices, when Meru needs to increase capacity, what we can do is provide another channel layers in those areas that need it. So for example, in larger auditoriums, maybe in classrooms that have grown from 30 students, they're now housing 50. But what's unique here is that we're providing multiple RF channels and we load balance across those for that environment. So effectively what we're doing here, let's say we have an 11N connectivity rate of 300 meg and we want more bandwidth, more density, When we put in another channel layer, we have 600 meg in every square inch of that chosen environment, etc. So it's a different approach than the traditional microcell. In the microcell, they're trying to power tune down to give one solid channel to every user. We can actually stack channels. We show 3 here, but then we can load balance across the 5 gigahertz space as well for those clients who do it, and really bring in a very large amount of bandwidth as required for the applications. So Meru's approach to solving this environment, very unique, very scalable. We're in control, and really provides the optimum environment for clients. So at this point, we have a few poll questions along the way. I want to bring up the first one. So I believe Patty is going to push out a poll question for me, and it's simply this: how would you classify your wireless service today? So the first being hotspot, which would be you just have a spot up occasionally, you're probably not managing it. The second would be pervasive across your environment. So pervasive meaning you have a signal everywhere, but it's not up to the level of mission critical and mission critical fault tolerant. So a few options for you there. The poll's open. I'll pause for a couple seconds, have a little sip of water here, and then I'll move along.
The first poll that actually launched is, how does your organization monitor and manage your wireless network?
Oh, I see that. Okay, we're going to get to that. Well, we'll do that one first. So, okay, so I do see that first poll question. We're going to get into how you do manage your network. So the first one is really, this first poll question then is, are you using any special tools to monitor your wireless network? Are you using tools and process the same as you do from your wired infrastructure, more specific to wireless, or maybe you outsource it? So we'll move along, and then I'm sure we'll have this other poll question coming forward. So I do want to talk about next generation Wi-Fi. I think this is really critical right now for everybody to take a look at. We've been focusing a lot over the last 4 to 5 years on rolling out 11N connectivity, which has absolutely provided great value to our clients. But that hasn't affected too much, I think, the overall architecture going into even the wired space. But this next, what's coming forward, I believe will, which is 11AC. So if we actually look at another study, they're saying there's going to be 300 million 11N devices out there in the world by 2015. In the same study, they're saying there's going to be 1 billion 802.11ac equipped devices by 2015. So while the top is great growth, and we're addressing that today, what's coming right along in the near future is 11AC. So what is 11AC, and what is it providing to you? So I actually pulled this chart just off of Wikipedia. It's a fantastic place, actually, to get some solid wireless information. 11AC is really the next generation technology after 11N. And what is being released, and what you'll see to begin with, is really in the second row is a technology that's going to provide 867 meg to the client. And for those who are more technical on the call, you'll notice that we're using much wider channels. So 11N typically, well, it does use 20 and 40 megahertz channels. 11AC is being designed to use 80 and then also 160. So 867 meg is going to be the first iteration coming out. And we do expect, as time goes on, that you are going to see gigabit speeds, again, down to stations. So how close are we to actually seeing this? Well, these standards, typically these pre-standards start to show up in the consumer devices to begin with. So at the Consumer Electronics Show, the latest one, Buffalo actually demonstrated this technology, and you can see a screenshot there showing connectivity of 783 meg. But I think what's even more important to look at is this month, Netgear is shipping the first 802.11 AC router for your home. So I believe that is, I know I actually pulled this from their website. It's listed on Amazon. You can order it now. I don't think it's shipped, at least as of last week. I think it was a couple weeks out from shipping, but it's announced and it's there. So again, this first generation expectations here would be connectivity for 867 meg. That's the router consumer side of it. From a client side perspective, just saw an announcement that Qualcomm, Theros, is now putting these chips in, and you can see a tablet here that's having the 802.11 AC Wi-Fi module. And Apple, the driver of all things BYOD, nothing official that anybody's seen. As we know, Apple's very secretive, but the Mac rumors in January said that most likely you're going to see some sort of Apple device this year adopting this 802.11 AC technology. So the next wave is going to be an environment where these tablets, these devices have a lot more bandwidth than they're used to using today. Another thing that is will be hitting your environment, and if you think back to that picture of the Super Bowl and Madonna, is that the carriers are also struggling with how to get more bandwidth to their users, again, using iPhones, using Droids. So one of the things they're looking at, there's multiple standards here, so I'm not promoting any certain standard, but what it really comes down to is that in the presence of a Wi-Fi network, there's standards being built so that data that traditionally is being run over a 3G or 4G network will be offloaded to the Wi-Fi network. So from a design perspective, if I'm a school, if I'm an enterprise, and I have users bringing in their own devices that are dual mode, in the pretty near future, I would expect to start seeing a lot more traffic coming from these devices over your Wi-Fi network. So you can envision and imagine, Facebook updates and these things that people are used to doing on their phones are now going to be traversing your Wi-Fi network. Clearly, there's a security implication there. I'm not going to talk a tremendous amount about that today. Really what I'm going to focus on is what does that mean to your network and bandwidth requirements. So from a new wired design perspective with where we are now and what's going forward, I kind of have to take a look at what's the traditional office design. And by traditional, I'm thinking really here mid-90s up through early or mid-2000s, is that we're designing networks so that people could plug in desktops and sometimes laptops. We would have switches at an edge, for an access layer, and then we tended to have a distribution layer and a core layer, and that has served us, very, very well. And that's, the typical designs that are there. As we move forward, what you're going to find is even though people may have laptops, if they have good Wi-Fi, they're probably not even connecting into those ports in their cubes. So the edge really is, and it's just going to keep going this way where it's going to be wireless. It will become the primary versus the secondary. So at this point, we really need to start thinking about what is in the closet at the edge, at that access layer. And again, traditionally what's been there has been 100 meg switch ports, but now I have technology not only with 11N with 300 meg connectivity for clients, but with 11AC, it's just going to go up quite a bit. And what we don't want to do is end up in a situation where we have switch ports that are paid for and not being used, and a lot of times without the bandwidth to support the wireless users. So here's actually a case study Gartner did, and it actually was in 2009, so it's a little dated, but I think it really makes the point. They did a study for California State University, and they found that based on this phenomenon that they could effectively reduce their costs 50% by eliminating ports at their edge, wired ports at their edge, again, because of the wireless demand that was being used. So, this 50% of the wireless ports are accountable for future growth. And I know on the wired side, traditionally, we always design for more ports for the future. Going back to late 90s and through the 2000s. So it's really an area we should be looking at as we go through wireless or wired refreshes, is putting in devices with possibly less ports, but technology that's supporting gig at the edge. The access points that ship today with 11N are gig ports, so taking full advantage of that, providing the best experience for your end user is critical. So here's our poll question as we're going to shift to the organizational aspect. So basically just asking, how does your organization monitor and manage your wireless network today? So it's a function of we don't. Again, same tools and processes of the wired network. Wireless specific monitoring and managed tools, or a combination of both, or maybe outsourcing. So Patty, not sure if you want to push out another poll, maybe the first one, or if that'll be pushed out as we go.
I'll do the how does your organization provide guest wireless access today?
Okay, be the next subject. So that's fine. So the poll you're seeing there, we are going to shift here in a little bit to the guest access. You know, do you provide guest access? Do you provide non-secured access? Do you hand out a pre-shared key to each user coming in? Do you manually provide unique credentials for each, or do you have an automated process? So shifting back again to the operational, again, based on a lot of my experience being with Meru over the last 5 years, and for those early adapters that are really trying to move to an all-wireless environment, there's a lot of reasons that the wireless network doesn't work. Usually a call come into the help desk and it'll say the coverage doesn't work, or I can't get connectivity. It tends to be one of those two things. And there's a lot of reasons that could be behind this. Beyond the interference that we mentioned, for example, like with microwaves in the RF layer, on that back-end layer, could be reasons the users don't input their credentials correctly when they're using secured authentication. Their credentials have expired. Authentication servers may be down or overloaded, which people can tend to be surprised, but in a wireless environment where every user is connecting that way, when we use protocols such as WPA2 Enterprise, the Radius server in that environment takes a tremendous amount of traffic for the 802.1x. And I've seen scenarios where the Radius servers have just completely been overrun. Again, with all these devices coming on, the DHCP pool sizes are going up dramatically. Planning to scope those correctly so you don't run out of IP addresses. And I've actually seen scenarios where, again, DHCP server has been in an environment for a very long time and it's doing just fine on the wired side. But when you get that many clients and expansion, it doesn't hold up. So these are all areas that should be looked at. And there's some other things shown here that are more traditional on the wireless space with driver configurations, or actually even having the wireless switched off. We occasionally see that people accidentally hit the button on their laptop. They'll call in and say, hey, I can't get access to the network and the wireless is down. So there's a great volume of these sorts of calls that occur when you start moving to this all wireless environment versus the wired. And it can be especially difficult, again, in that 2.4 space. So really the realities here of the typical wireless LAN management is typically you get these calls, and a lot of times these calls could be a day later, and in order to get to root cause, you have to have some mechanism in some way to go back in time and eliminate the problems after they actually arrive. So, for example, if I had a conference room or an auditorium just full of people and we had 1 or 2 user complaints in there, the next day when you walk in and that room's not being used, most likely the wireless service is going to be perfect. So it's very hard to go back later out on site to find the same issues. You need to find it when the issue is actually occurring, or have the tools to go back in time. The next comment about increasing the scale of the network, which we're doing, is typically you want to try to do that without adding a lot of IT resources to your environment. Most every customers I run into have dedicated wired side resources, but I would argue that as we're moving today into this arena where wireless is the default for access, we need to provide training for these wired administrators to really, with the tools and have the questions to really handle these issues that occur. Again, finding root cause can be difficult, and it's an area without tools. You can spend an awful lot of operational time. So the way Meru addresses this, and again going back to this unique differentiator of a single channel, we actually have a product we call our Service Assurance Manager, which gives you the ability to proactively determine the status of your wireless network. So what we actually do here, since we operate on a single channel, is we push a virtual client out to an access point. That access point will then query our controller for the type of security, type of profile that the actual user is connecting with. And that virtual client will connect to all adjacent access points. And then we'll run connectivity tests, throughput tests, latency tests. And that virtual client shows up on our system just like a real client would. It goes through the NATO 2.1x sort of session. We provide virtual credentials or test credentials to that. So it goes all the way back to the Radius server. This virtual client takes a DHCP, gets an IP address from DHCP server, etc. So what we can do here when we do this, push this virtual client out that then walks through the wireless network, is we can baseline a healthy network. Or the first time we run it, we do have settings. We can show you where the network is not functioning well. Once we have that baseline, what you then can do is run that test continuously, run it once a day, run these same tests, once a week, depending on your environment, and we trend these over time and proactively notify you, so you can see that your network maybe start having issues, and you can proactively address that. So that's the proactive side of it. On the going back in time side of it, what our system also does is we capture all the state changes of every wireless client that ever touches our network, and we can go back in time. Some of these actually trend back a year, but we go into specifics back to 6 months. So if someone ever comes to you and says, I had a problem connecting into the environment 3 weeks ago in a particular room, you can, based upon that person's username or the unique MAC address of their client, go back in time and see exactly where they were, see if they were able to authenticate, see if they got an IP address. You can also see if other users were on at the same point in time. So this technology is very important in an all-wireless environment. It's something that's been built in the Meru product for several years, and I can tell you firsthand has really brought the operational burden down on our customers. So very critical from an operational perspective. I do want to switch into user provisioning. This ties into the BYOD. We won't push this poll question up right now, but it is again, the guest access poll question, what you are providing. So I'm going to move along to the next slide. So the challenges here are, how do you easily, that I walk into, we'll walk in and we'll see a guest in the clear SSID in the air, and a lot of people just connect into that. Sometimes there's captive portals defining use rights. Sometimes there's not. So that's really out there a lot, wild in the environment. And one thing I've removed from this slide, because I don't know that Congress can pass anything now, but there's actually bills up at Congress that have been circulated around that would require providers of guest networks to be able to monitor and audit users and what they're doing. Clearly, from a cybersecurity perspective, anybody walking into a guest environment or sitting in a park into the internet can go off and do certain, things that may not be in the best interest of all. So having those open guest accounts not only from the security perspective of the individual client where they're broadcasting in the clear, but I think going forward in the future, we're going to see some pressure to gain control of that. So in this BYOD environment, if you have to start providing unique credentials, secure credentials, that can become, very time-consuming and a big burden on the staff. So, how do you handle that? Meru actually has a solution. It's called our identity management system. We purchased a company that really gives the ability to assign unique credentials with the security policies that you desire. Could be pre-shared key, could be WPA2 Enterprise, WPA, etc. And gives the ability for anyone to give users rights to gain access to the system. What we call this is a sponsor. So the example here is if I would happen to go into VDN and I go into the conference room, I'd say, hey, Frank, I'd like to get access to the internet while I'm here. Frank says, Chris, I know you, no problem. Frank logs into a website, maybe puts in my mobile phone number, just something to identify who I am. The system will uniquely generate credentials for me, and it can deliver those to me via email, via text message, multiple ways. Frank could even print out the information. And so in that way, we're not putting a burden on an IT administrator or the security organization to create those unique credentials. We know who has given me access, and in this scenario, the sponsors have unique rights too. So maybe Frank can only give me an hour access per visit. Maybe we trust Frank more and he can give me a month access based on who he is, etc. So we're defining separation of duties and access rights not only for the guest client coming on, but also for that sponsor. What makes this more exciting, and when you start thinking about what are all these devices coming in, the BYOD devices, is to actually automate the process of configuring the end device. So I happen to carry a Droid around with me, and even though I've been in the wireless space for a long time, if I have to go in and configure WPA2 Enterprise, or it can be very difficult just to get around the screens on the Droid. I can do it every time in a Windows environment, but on the Droid things are have different labels and such. So now as you're talking about guest users that don't have real deep experience in this world, how do you actually help them to come onto your network? So what's showing here on this screen is this captive portal that the user would see, which we're traditionally used to seeing on the left. When they do log in this case with a username and password, they're presented with another screen. And again, these things are all customizable, but essentially there's a button there that says, click here for a secure connection. And based on the device type that you have, code will be downloaded to the device, and it'll configure the device to get on in a secure manner. What we're showing on this slide is an 802.1x security profile being used. The great news about this, too, is if I happen to get rights from my sponsor or the visiting organization that say, hey, give Chris access for the next year, every time I come back into the environment, I have these unique credentials. I don't have to go through the captive portal anymore. I've already clicked the button to say I agree with the terms and conditions. And in that way, I'm really providing a great, secure experience for that end-user guest coming into the environment without creating a huge burden upon the IT organization. So from an end-user perspective, with the example of an iPad, this is what it would look like. Again, person logging in, they've been giving this username and password by the sponsor. You can see here that there's code being downloaded, and the person would actually have to click a button that says they accept it. And then it's auto-configured, and the user's put on a secure network, which can be mapped also to secure VLANs. So a very flexible system that works very well with different security policies and use cases out there. So definitely encourage your organization to consider such a system. This technology also works for wired environments and even environments that aren't Meru wireless. We actually work with our competitors' wireless systems providing the same technology. So finally, with everything that we've discussed, the existing technology, the new technology that's coming out, the effect of BYOD, guest management. I just want to finish with a few slides on really design requirements as you're architecting your network, what you should be looking at. So first and foremost, really be thinking about the current density of the clients as well as the future density. Understanding that you may have times when you have rooms that are relatively free of people and other times extremely crowded. And that in those environments, a standard Wi-Fi solution is just not going to be able to handle that because they're using this collision avoidance algorithm. So you really need to look for a flexible, system that has the ability to scale clients up quickly and has the ability to handle this contention loss conundrum that's really out there with the standard 802.11 protocol. To give you a feel for that future density of clients, one of the major universities in Illinois that we work with called us in January, and they were having some performance and throughput issues in one aspect of their network. So we went down and took a look, and what we found was that just between December of 2011 and January 2012, their client connectivity rate went up 50%, literally 50% more wireless clients on the network. So anticipating, understanding what's going on in the environment, this was the year of the tablet as far as Christmas, in conjunction with using these proactive tools to understand how much bandwidth you have being utilized, how much headroom you have, to be really critical. So monitoring, again, proactively your network to understand how much capacity you have going forward to provide that great experience for your client. Without a doubt, the future bandwidth requirements are just going to keep going up. So again, what's happening in the cellular offload, the change in the standards, clearly expect the bandwidth to go even higher than what we're seeing now. Other design requirements is really then also to try to take a look at the critical applications versus the casual. User expectations now are that if they can't hit the internet, that they do get pretty upset. But those are still a little different than other applications such as voice devices that are used in hospitals or alarms. So one of the unique capabilities Meru has with this single channel, single layer technology, we've seen some of our customers actually design and engineer their networks such that those absolute mission critical applications are residing on a separate channel that is known to be very clean and very solid throughout the enterprise. So with that, that's a segmentation of the application. But even with that, the system still is going to need to proactively, out of the box, dynamically recognize when this is data, when this is voice, when this is in video, and apply the correct QoS. And again, that's something Meru does. We recognize SIP clients on iPhones and other devices. We recognize video streams, and we make sure that they have all the bandwidth they need in order to operate. So on the wired network readiness side, again, I touched on really examining DHCP servers and scopes. I've seen LDAP servers completely overrun with CPUs, 100% utilized, not returning information fast enough, so the wireless users having problems getting on. So the whole back end of the authentication servers, whatever you're using today for secure wireless, as well as the DHCP scope, should really be looked at in the light with your user count just dramatically expanding. And then also, at the edge, great opportunity to save some money is to take a look at what the actual use is at the edge with your wired switches. Clearly, you plug in one access point, an access point servicing 30, 40 people, you're going to dramatically reduce the number of ports that are out there. We touched on the absolute need as this, again, becomes the primary mode of access into your information. Make sure you have the proper wireless tools. So those will be tools to monitor what the clients are doing, giving you predictive and historical information so you can make some good intelligent decisions on any changes that need to be made to the architecture. monitoring interference and not really Wi-Fi interference. That can be a problem, but traditionally the non-Wi-Fi interference, such as microwaves, cordless phones, are those that cause the most damage. So really understanding your spectrum, especially in that 2-4 space where these devices are. And that will help you then again to manage, what channel should I be on, do I have capacity, etc. Finally, automating this guest and BYOD connectivity and policy, that is hot right now just because of the demand it is applying to IT organizations. And the top logo, which I actually have shown here, for those education customers, we used to do road trips in college where we'd go off and we'd be thinking about parties and we may have a cooler in our back seat. But today there's something actually called EduRoam that the universities, a lot of the universities are taking part in, where a user at one university that has EduRoam credentials can go to another university and use those same credentials to access the wireless network and get into the environment. So in the education space, we're starting to see a need for provisioning guests, not only those that are just coming in out of the blue to your organization, but those that are also affiliates with your organization. So my expectation is that as that starts to mature, we may start seeing the same thing across verticals or other companies that have partnerships with other organizations. So definitely should be thinking through those things. And then finally, I think there's cost reduction opportunities in this. Clearly anytime there's change and there's re-architecture, there's some investment that can occur. But from a capital perspective, saving funds on what may be a wired infrastructure refresh. Again, purchasing devices with less ports, but maybe higher speeds, definitely opportunity there. I'm seeing organizations actually leverage the BYOD phenomenon to save money. Instead of providing traditional laptops, there's certain job functions within the organization that a BYOD device satisfies. In that perspective, some companies I've literally seen, they say, bring your iPad, bring your Droid tablet, you can just use that, and they're not providing a laptop per se, again, based upon job function. Or I've seen organizations that are providing a stipend, go out and choose your own tablet, and traditionally, those are much less than a laptop or desktop fully loaded with the software. I haven't really seen this as of yet, but one of my thought processes is possibly negotiating with carriers. If they're going to be offloading traffic onto your networks, might be a good discussion to have if you have a carrier provider of choice for your organization. And then lastly, on the operational side of things, I've seen this really cut both ways in that organizations that aren't prepared for the calls that they're going to get when they completely open up their environment for the wireless technology can spend additional man-hours and time troubleshooting. So this management becomes a lot more critical, in my opinion, than the traditional wired port management, because this is way beyond the port up and down. It really is being able to look in and see what is that wireless device doing. So investing in, even minimally in some of these management tools can really help you save a lot of money on the operational side of things. So with that, that is my presentation. I'll turn it back over to Frank Media.
Great. Thank you very much, Chris. Thank you all for joining us today and actually staying with us, given we went over a little bit here. If you want to discuss this topic further, please do contact your VDN account executive, or you can see our phone number on there. We'll promptly get you in touch with one of our account executives. And when you leave our webinar, there is a parting questionnaire that we'd greatly appreciate you answering. It'll assist us in with educational topics that you're interested in that we could provide to you at a future time. Thanks a lot, folks. Have a good day.